Good morning. This is going to be the I do video. So today we're going to look at the power rule and trigonometric derivative rules as long as projectile motion problems. This document includes all of our rules. We're going to get to the exponential and inverse trigonometric and logarithmic rules later on, as well as the product and quotient rule. So today is really just putting our foot in the water. Remember, the first derivative is going to be the instantaneous rate of change. All right. As opposed to the average rate of change, which is the slope of the secant line. These are our general derivative rules. Pause the video and take a moment to write these down. The same is true for these specific rules. All right, take a minute, write these down. So pause the video here. Pause the video again. All right, so we've already talked about the derivative and the tangent line problem, but I just wanted to remind us of that equation because it is important. And next up, we're going to talk about projectile motion. So projectile motion has an equation that we're going to be looking at, which is S of t equals negative 1/2 g of t plus 0t. So this g is going to be gravity, and that's going to depend on the unit. So it's 32 feet per second squared, or 9.8 meters per second squared. So it depends on the unit of the problem, which one you're going to use. V0 is your initial velocity, and S0 is your initial position. So let's go ahead and look at one of these problems. So we're given at time t equals 0 seconds, a diver jumps from a platform 32 feet above the water. So our 32 feet above the water is going to be our initial position. The initial velocity is 16 feet per second. We're looking for when the diver hits the water and the diver's velocity at time of impact. So for this, we're going to be using the power rule, which says the derivative of some function is going to be equal to the power pulled down and then one smaller. So this is for when f of x is equal to x to the n, the derivative is equal to that. All right, n is just a constant. So let's go ahead and set up our equation. We've got v of t equals, we're in feet now, so we've got negative 1/2. We're using the feet gravity, so 32 t squared, plus our initial velocity, 16t, plus our initial height, 32. So I've got v of t. I'm sorry, this is s of t, my position. Yikes. All right, so I've got negative 16t squared plus 16t plus 32. So let's go ahead and look for when we hit the water. So our position when we hit the water is going to be 0. And this is just us finding the roots for this problem, or the x-intercepts. Well, in this case, when t equals 0. So this one is a pretty problem. We can factor it, so we're going to go ahead and do that. We'll pull out negative 16, our greatest common factor. And that'll leave us with this expression, which is factorable to t minus 2, t plus 1. So s of t equals 0 when t equals 2 and t equals -1. We're not looking back in time, so it's going to hit the ground when t equals 2 seconds. All right. Well, our diver is going to hit the water when t is 2 seconds. Now we need an equation for our velocity, so that's where this derivative is going to come into play. And the reason that is because the derivative of our position is our velocity. So we're going to talk about this more in class. All right. But we're looking at our original equation here. We're going to use the power rule. So our power rule says we take the exponent down, and we multiply it times the variable. So our exponent here was 2. So we're going to take that 2 down, right? It's t squared times -16, t to the 2 minus 1, plus the exponent on 16t is just 16. Is 1. So we've got 1 times 16, t to the 1 minus 0, plus, and the derivative of a constant is 0. So I've got -32. T to the 2 minus 1 is just t to the first, or t. 1 times 16 is 16. T to the 1 minus, this is 1 minus 1, is 0. And t to the 0 is just 1. So we've got 16 plus 0 is 0. So this is our velocity equation. And we're interested in the velocity at time of impact. So that's going to be the velocity at 2 seconds. And when you do that, you're going to get 48 feet per second. Well, -48. And that makes sense because we're going down. So we're going to do some more of those problems in the we do section. So if you're like, what? I don't get it. We've got another take on it. Then we've got some basic differentiation we're going to look at. So these first 6 problems are all going to be the power rule and the trig rules. So power rule, remember, says for x to the n, our derivative is going to be that exponent pulled down and then made one smaller. And cosine x, our derivative is negative sine x. And sine x, our derivative is cosine x. All right, those are rules that you wrote down up top. So let's go ahead and do these. The first 3 don't require us to do any real heavy lifting aside from just apply the power rule. So my exponent in the first term is 4, so I've got 4 times 3, x to the 4 minus 1, minus 2, my exponent times 9 to 2 minus 1, plus 10, it's 1 times 10, my exponent on the x is 1, x to the 1 minus 1. All right, so we've got x to the 0 here, so that's just going to be 1, so our last term is 10. Then we've got -2 times 9, which is -18. X to the 2 minus 1 is x to the first. Then we have 4 times 3, 12. X to the 4 minus 1, 3. Same thing over here. Let's pull down our exponents and then make the exponent ones smaller. So I've got 2 times 3/4, x to the 2 minus 1, minus 9, minus 9 times our exponent 1, x to the 1 minus 1, and then plus 0 because it's the derivative of a constant. 2 times 3/4 is 3/2. X to the 2 minus 1 is x to the first. Then we have 9 times 1, which is 9. X to the 1 minus 1, x to the 0, which is just 1. And then we have plus 0, so that guy disappears. Next up, This one's written in terms of y equals, so we're going to use dy dx, our alternate notation for a derivative. Pull down that exponent. 4 times 13, x to the 4 minus 1, minus 2 times 10, x to the 2 minus 1, plus 0. So we've got 4 times 13, which is 52, x to the third, negative 2 times 10, negative 20, x to the first, and 0, so we don't have to write that one. This one we're just applying the cosine and sine rules, so the derivative of cosine is negative sine. So we got negative 18 sine x. That constant out front just hangs out. And the derivative of sine is positive cosine, so we got plus cosine x. These next ones have some fractional exponents. So the one on the left-hand side we don't have to rewrite, but the one on the right-hand side we're going to have to rewrite before we do the derivative. So we've got the same rule, pull down your exponent, times your existing coefficient, and then make your exponent 1 smaller, so 4/5 minus 1. Then we have 1/4 times 16, x to the 1/4 minus 1. So negative 3 times 4/5 is negative 12/5. X to the 4/5 minus 1 is negative 1/5. And then we've got 1/4 times 16, which is 4. 1/4 minus 1 is negative 3/4. So those negative exponents bring us down to the denominator. So I'm going to negative 12 over 5x to the 1/5 minus 4 over x to the 3/4. All right, I didn't ask you to put it in radical notation, but if we were to, then that would become 5 and the 5th root of x. The numerator is just 1, so it would be the first. And it's 4 over the 4th root of x to the third. So I didn't ask you to do that, but were I to, that's what would happen. This one we have to rewrite. So the 8 is our numerator, and the root is our denominator. So we got 3 over x to the 8/3, and then we need to bring it up top. So before we do the power rule, we need to have our variable on the numerator. So it needs to be up top using a negative exponent. Right. So then we do our derivative, pull down our exponent, make the exponent 1 smaller. We're going to have negative 8x to the negative 8/3 minus 1. So that would be negative 11/3. So we've got negative 8 over x to the 11/3. And then if we wrote that with a radical, that would be negative 8 cube root x to the 11. So I know that was a lot. Go ahead and pause the video, rewatch parts if you'd like, and then try the we do problems.